Alright, hi, welcome to the first class. Today we're going to be looking at the basic introduction to Java and object-oriented programming as well as high-level programming languages. So let's take a look at what we're going to do today. My interest in computer science really started growing when I was about 4 or 5 years old. And my dad obviously works in the tech industry, so I watched him work when I was a kid, and so I'd look at what he did and try to mirror that, and obviously I was much younger, much less mature than him, so I would just mess around on the computer just to have fun. And soon enough, that started growing into a sort of a passion to do what my father did, and ultimately kind of grew into a desire to learn programming. And I didn't take courses or any sort of thing, and in retrospect, maybe I should have, but I learned doing it the hard way. I kind of, without any guidance or without any teachers, I just kind of threw myself into it, and I tried and I tried. It took a long time, but I got there, and since middle school, I've been kind of going at it based on a personal standpoint. When it came to high school, I started going for internships and all that sort of stuff that involved programming and tech work. I started taking classes like APCSA, which is what's covered in this Java course, and uh, yeah. Okay. So on our agenda today, we have just a brief introduction to Java, talk a little bit about history of computing, where computers come from, what they do, a little bit about the Java compiler and interpreter, and finally we'll do a hands-on code along for the Hello World program, which I'm sure many of you are familiar with. So let's start with what are computers. So computers are actually a lot different from what we think about today. Computers aren't just laptops and, Windows or Macs or all that stuff. Computers actually, sort of a general definition, is just a programmable machine which manipulates data according to user input or otherwise provided instructions. And it really helps humans in performing difficult calculations. And we'll take a look at these instructions later. That's actually what our program is going to do, and we have a special word for it that we'll talk about a little bit later in this class. And this sort of generalized definition for a computer makes sure that it encapsulates a lot of machines that came before what we think of as computers. And so they initially referred to people who did these difficult calculations. And in fact, one of the first machines that ever was termed as a computer was the abacus, and it was one of the first examples that calculated and did basic arithmetic. It could add, it could subtract, all that sort of stuff. The slide rule was one of the most basic computers as well. It could do a lot of trig, could do logarithms, could do multiplication, division, basic arithmetic operations which couldn't really be done by humans back then could be done by these computers. And after computers, the next evolution of computers really came through with the central processing unit, which is known as today as the CPU. And you may know that all your computers have CPUs, your phone has a CPU, pretty much every piece of technology we own, which is in a sense smart, has a CPU. And essentially, this was theorized in 1945, right after World War II was completed, by von Neumann, and he proposed this architecture, theoretically, which could have revolutionized technology. And this architecture, what made it so great and so useful even today, is that it was extremely malleable, which means that it could be changed in all sorts of ways while retaining that sort of basic architecture that von Neumann proposed. And it wasn't it didn't have a lot of wires and all that sort of stuff, which made computers before that so bulky. And we'll see how the computers after that, after von Neumann's proposition, evolved, and we'll see how they got a lot smaller. And the basic architecture of von Neumann's CPU had 3 units. Had the arithmetic and logic unit, the ALU, the control unit, and the memory unit. So the memory unit obviously is onboard memory. Arithmetic and logic unit is where all of the sort of mathematical operations, all the binaries computed. And let's actually take a look at some of the old computers that came after von Neumann's discovery. So the first big modern PC was the Harvard Mark 1. And the main aspect of Harvard Mark 1 was that it was electromechanical, which means that it still had a lot of moving parts compared to what we see now. Obviously, even today, we have some moving parts. We're trying to phase them out, but the hard drive is essentially a moving part. It has a spinning disk inside, but this had a lot of moving parts, and that made it susceptible to failure. And obviously, we want less moving parts. So the next came the ENIAC, which was the first general purpose electronic computer. And you may have noticed that we went from electromechanical to electronic. So we're getting rid of some mechanical components here and making them electronic. And the first computer that we could buy, the first commercial computer, was the UNIVAC 1. And this computer was the first commercial modern computer, which means that it's sort of like the grandfather of all the computers we have now, grandfather of any Windows PC or Mac or that sort of thing. And so now we know about modern computers, let's talk a little bit about what we can use these computers for. Since computers are just tools, we have to decide what to do with them, and that's what makes them really special, right? So mathematicians actually developed this thing called algorithms, and it's just derived from algebra in ancient India and represent a set of strict action to accomplish a certain task. Essentially, it's sort of a recipe book for computers to follow when doing a certain action. For example, you may have an arithmetic sequence that you want to add up. It's just an arithmetic sequence, for those of you who don't know, is just a set of numbers with a common difference. 1 plus 4 is 5, 5 plus 4 is 9. So if you want to find the sum of those, you'll have to find each of the elements, maybe put it in an array or data structure, then add up each of the elements, and that's it. And so there's a lot more complex algorithms than that. We'll take a look at a couple like quick sort, merge sort, any of the quadratic sorts. And so these algorithms are really what make computers what they are today. And we'll take a look at these obviously a little bit later in the course when we're talking about looping, for loops, while loops, conditionals, recursions, and more complex programs. But for now, let's talk about what really makes Java run, how we can use Java to make the best of this programming language. And so Java is a high-level programming language, which means that it's one of the more advanced programming languages compared to machine language or block-structured programming languages. And what makes it run are two things: a compiler, which converts all these Java programs that we read and write, which are in plain English, into Java bytecode. And bytecode is a special term which just means a form of machine language, something we can't read. It's going to be in binary, it's going to be in weird symbols and all that sort of stuff that we humans can't read. And so when it's converted back to bytecode, we'll need a Java interpreter which interprets that bytecode, that machine language, and lets us run the program. And so there's a separate tool known as the Java interpreter. Some people like to call it the JIT compiler, which means just-in-time compiler, but I feel like that confuses people a little bit too much because we have a compiler and then we have a JIT compiler. So I like to call it the interpreter, and essentially it runs the compiled bytecode in real time, and you can see the output of your program, the fruit of your actions. And let's now go ahead and make a Java program, our first Java program actually. But to do that, we're gonna have to install a bunch of stuff. So I'll come back to you when we're installing that. Alright, welcome back to the second week of Java. This week we're going to talk about our first Java coding experience. And the first thing you'll see is this. You'll be greeted with this screen, and what do we do now? That's the first question. And the first thing we're going to do is define a method. And a method is basically something that the Java interpreter does. simply put. So the first method we're going to write is our main method. This is the method that gets executed each time the interpreter is called, or the JIT compiler, whichever you want to call it. So this method signature, what we're going to write here, is quite complicated, and you won't know this off the top of your head in the first couple of tries, but eventually you'll get to know it. So this, what you have to write is public static void main string 2 braces and then args, and then you'll do your opening curly brace and your closing curly brace comes in automatically. So what we need to do now is actually define what our main method is going to do, but before that, let's talk about what this is, what this line means. This is what is called a method signature. It's basically what Java looks at when it compiles. It'll take all these method signatures, and when you call a method, it looks at these. And for example, this one is public, which means that anything can see this. Any other class, any other object can see this. Static we'll get to a little bit later. Void actually just means that it doesn't return anything. A lot of methods return values, and we'll talk about that a little bit later too. And like I said, this is the main method, so its name is main, and it takes these parameters. And we'll talk about this type a little bit later. It's a very special type that is used quite often in computer science. So let's try defining something. And the first thing that most people do is the hello world. Hello world is, if you're not familiar to programming, where you just tell the compiler to print something back at you, and that's how the program ends. So let's try that. The way to print in Java is actually quite complicated compared to Python, for example, where you could just do print whatever you want to print, hi, for example. And you'll notice that our compiler immediately does not like it because print doesn't make sense. It doesn't like it. So let's try this instead. System.out.print hello world. And when we do that, it's not red anymore, which means that it looks good to the compiler. And so let's try running it. This green button up here runs it. And so if we run it, it'll tell us select resources to save. You just hit OK. And boom, there we go. We got our hello world right here. So that's our first experience with hello world. Let's try printing some other stuff and we'll come back to this. Alright, so now that we've finished our first printing experience, printing hello world, let's try printing some other stuff. Like for example, what your name is or where you come from, all that sort of stuff. So if we want to print on another line, we want to change this command. Do you notice how we have system.out.print? We want to change this just slightly, put an ln there. And you'll notice that this is fine with the compiler because it doesn't complain. And this actually means print line, which means that it'll print whatever's in here, excluding the quotes, of course, and then it'll print a new line. So it'll go to the next line. And let's actually try this out. So if we have another print, we're just going to print something else and have print line, and let's try and print my name is Bob. There we go. And again, don't forget the most important thing in Java coding is probably the semicolon. Don't forget that. Put that in there and the compiler stops complaining. Let's run it as always. Hit OK. And there we go. So we got hello world, and then on a new line it says my name is Bob. Now let's talk about what would happen if you didn't put the ln there. If you just put print like we did before. So if we didn't do that, what do you think would happen? Obviously, if you don't have print line, it's not going to print on a new line. So I would say that it would print hello world, and on the same line it would print my name is Bob. So it would read like more like a sentence. So let's try that. There we go. And it's just as we expected. They're both on the same line. There's not even a space between these. If we wanted a space, we could do this. But the new line is added only by the ln. So if we want to have a new line there, we need to put the ln there. Here we go. So let's keep going. And if we want to print repetitively, we can just put whatever we want on a new line, finish it with a semicolon, and that should work just fine. My friend's name is Billy. Finish that off. You can even do a little bit more. Sim.out.print. Done. So that's going to be our last line of our print sequence. Let's see how it comes out. Hello world, my name is Bob, my friend's name is Billy. Notice that since I did print, it doesn't go to the next line, but after this one, it does go to the next line. And then done. So this is our first experience printing a sequence of things. And in fact, let's change this completely and let's start printing something else. Let's start printing a sequence of numbers instead of a sequence of sentences. So let's try printing 1, and then we can print 2, and let's print 3. And you'll notice that even though I'm printing numbers, I'm putting quotes around them. And we'll get to that a little bit later, but essentially what we're doing is we're putting numbers in strings. So we're taking them as literally as possible. So we can put anything in here. We can put that in here, and it'll take it as a string. So it'll print it just as it looks. And there's special escape characters, which we'll look at in a little bit. But for now, this is just taken at face value. It's just going to print 1. And let's take a look at how that looks. No surprises here, just prints 1, 2, 3. Alright, so now that we're done with printing, let's get to talking about some types. Alright, so the first type that most people talk about when they talk about any programming language is the classic integer. And Java has a beautiful way of handling types, which is really easy for beginners. You just type the name of the type, or I should say write the name of the type. For in this case, we don't type integer, but we type int. And then you type the name of the identifier, which is what we're going to call our variable. So let's call it my first number. And then you put an equal sign, and then you put whatever value you want to give it. So since it's an integer, I can think of, say, 1, for example. So we've defined an integer called my first number, and it's equal to 1. And this is actually an example of an assignment operator. So what this does is it takes my first number, which is the identifier. It's the name of our variable, and it gives it a value of 1. So it copies over this value into this identifier, and it's of type integer. So what we can do is just print it if we want. We just print my first number. And let's try that out. And there we go. We printed 1. And in fact, we can change this to any value. Let's change to 100. And we'll get out 100. So Java's quite versatile like that. And later in when we talk about classes and instances and all that sort of stuff, we'll talk about how we can most effectively use Java to control our program. So let's actually talk about a very important distinction, which is how printing variables differs from printing strings. So what we did before was we put whatever we wanted to print out in quotes. A lot of people may be asking, why didn't we put this in quotes? Well, the simple answer is that this, as you can see, when you highlight this, this also gets highlighted. So this is an identifier for that. So when you call this, Java thinks of this, and then when it thinks of that, it knows that 100 is stored inside this, and it's going to print out 100. In this case, when you highlight this, obviously these are not connected, and it's just going to literally print my first number. So let's see how that works. There we go. So when we printed that, it referred back to this integer, and it printed 100. when we printed this, it referred back to 100 and it printed, it just referred back to this string and it literally just printed my first number. We can also print 100 like this. This is just going to print 100 literally like that, not as an integer, but as a string. And we'll get to strings a little bit later. But you can use this way to print 100, or in fact, you can print 100 this way as well. And this is the beauty of Java. This is an integer. This is a number. This is not a number. This is a special type called a string. And this is also an integer. So these two are actually equivalent ways of printing the integer 100. And you'll see if you highlight it long enough, it'll show up with the description. So this is an integer right here. Alright, so let's move on to what we can do with integers. Integers are very cool. We can print them, but what else can we do? Well, obviously we can define other integers. My second integer, we can call my second number, and let's define it as 1000. These two are both assignment operators now. And so what I can actually do is I can do system.out.print the sum of my first number and my second number. So this will actually take these two numbers, add them, and that's going to be equivalent to an integer, and it's going to print that integer. So that's how the command flow happens. And as you can see, when I highlight my second number, it refers back to this, and when I highlight my first number, it refers back to that. And so I predict that our output's going to be 1100 because we're going to add these two. Let's take a look. And like we predicted, it's going to add them, return that integer, and we're going to print out that integer. And you can even store this integer actually in another number. Let's say my third number is equal to my first number times my second number. So, as I said before, let's scroll back a little bit. This is the type, this is the identifier, the name of the variable, the equal sign, which separates the left side from the right side, and we have my first number, which is this number right here, my second number, which is this number right here. They're going to multiply, and we're going to get, I think, 100,000, if my math is not wrong. So our third number, my third number, is going to be 100,000, but we're not going to see it. So if we actually run this, we're just going to get at the same old 1,100. So to see it, we're going to have to print that out as well. So let's print line my third number, and like I said before, no quotes unless you literally want to print my third number. This refers back to this variable, whereas if you put it in quotes, it's just a string that it prints out. So like I said before, it's going to print 100,000 and then 1,100. Obviously, there are more operations that you can do. Let's define some of them. We can divide numbers equals, let's divide my first number and my second number. And actually, since we're doing a sort of pattern here, let's change this to multiply mul numbers and change this to div numbers. Let's make everything a little bit more organized. Let's try add numbers, my first number plus my second number, and you get the rhythm. So last one is just going to be sub numbers. It's my first number minus my second number. Now, some other operations such as the cosine, the sine, the power operation, exponentiation, all that sort of stuff are a little bit more difficult than this. These are the only operators that are supported quite natively, in a sense where you can just type the symbol and it'll interpret it as the operation. So what we can do actually is print each one of these out. System.out.print mul numbers, and then we can print out, sorry, I forgot the println here. Div numbers, we can do the println add numbers, and you'll notice that there's a little bit of a hiccup here that goes away as soon as, you know, the compiler refreshes. The last one is, of course, sub numbers. And we'll actually notice something quite interesting with the sub numbers. So we got 100,000. We know that's true. Divide numbers. Ooh, here's where something gets really weird. My first number divided by my second number, it says 0. We'll come back to that in a little bit. Add numbers works perfectly. And subtract numbers, there's a negative number. That's quite interesting. So we get negative number here, and this is a weird result, but let's just ignore this for now, and we'll come back to this in a later video. So now that we've explained how to do operations with integers, let's talk about operations with strings. Operations with strings sounds quite weird, but let's try it. Same deal. When you want to define a string, do the type. That's the type is string. You type in the name of the string. Let's call it my string. You do the equal sign. That's the assignment operator. That's the sign of the assignment operator. And then you put whatever you want in the quotes. So let's say this is my string. And of course you can have any sort of anything inside the string that you wish. So we have this is my string, and when you print this, it's just going to say this is my string. And an important thing when you're printing strings is that, again, you don't need to have quotes around my string because it's a variable, it refers right back to there. So let's just try this. This is my string, prints beautifully. Remember, no quotes in the output. And let's come back to this operation that I said we would do with a string. So let's call this my second string. This is my second string. And actually, we're going to do something a little bit weird here. We're going to put a space here and a period here. And you'll see very quickly why we do that. So we have two strings, and let's get to our operation first. The most basic operation with strings is called concatenation. And if that word is too complicated, it literally just means addition. We're going to add two strings together, and we'll see how we do that. So let's try it. My string plus my second string. It's very easy. You add these two strings, and let's see what happens. Look at that. So it joined this string, the first string, to the second string. And you'll notice why I put the space there is because to have a space right after the period there. So string concatenation literally joins two strings together. And you can put this in the print statement as well. So we can actually do a string. Remember, this is a string as well. And this is a string as well. So we're combining two strings, hi, and we're combining that with Bob, with the space in between. And we'll actually talk about the difference between these two very shortly. When we print that, obviously we get this is my string, this is my second string on a separate line because it's print ln, and then we get hi Bob. Now the difference between these two is that this one's in quotes and this one's not. This is a variable, a string variable that refers to a particular string. It's a string object actually. This is a string literal, which quite literally just means that it's a literal string. It just has words inside quotes. That's a string literal. This, for example, is also a string literal, but this string literal is stored inside this variable. So here we're printing out variables, and here we're printing string literals. And in both examples, we're concatenating them to make a bigger string with the first two strings. Now, I can see how that's a little bit confusing to you in the first couple of times that you do it, but don't worry, it'll get quite repetitive and natural. So let's talk about one last example of concatenation. In fact, we can combine string literals and string objects. We can concatenate them. So we can do my string plus here is another one. And let's go even further, do multiple concatenation, put even more things in there. So we combined one string object with a string literal and then combine that with a string literal. So let's try that. This is my string, here's another one, Bob. So that worked perfectly, and that is the essence of how to do a basic operation on a string, and it's called concatenation. Now let's try something weird, and that is putting a minus instead of a plus. Intuitively, that really shouldn't work, right? And as expected, it really doesn't work because the operator minus is undefined for the argument type string. How do you subtract two strings? Well, there really isn't a way to do that. So here, this was just a brief introduction to types, the integer type, the string type, and a couple of the most basic operations you can do with those. See you in the next video. Alright, welcome back. Let's talk a little bit more about what else we can do with integers and strings. Some special things we can do here and there. So something that I forgot to mention in the last video was that you can actually put operations inside the assignment operator. And that sounds a little bit weird, but let me show you. So as always, to define a variable, any type of variable, you need the type, which is the int, which is integer for now. Let's call it a, and we'll get back to why a is a bad name, but just for now, we'll have it called a, and we can do 10 plus 10. So this actually, what it does when it evaluates is it obviously returns 20 because 10 plus 10 is 20. And then it's going to store 20 inside A. So before it actually stores the value, it's going to evaluate this mini expression inside this assignment expression. And we can make this more complicated if we want. 10 times 10 plus 10. This is going to be 10 times 20, which is 200. We can have another integer even more complicated, 10 divided by 2 plus 5 times 10. This is going to be 50 plus 5, so 55. And then we can have even more crazy stuff. We can have a times b plus b times a. So Java gives you a lot of freedom with this sort of expressions in the operators. So expressions and operators. So we can do pretty much anything on the right side of an assignment expression, and we've done that here. So let's actually go ahead and print the values of each one of these. So remember, no quotes unless you want to print a literal string, which means that you want to print literally what's inside that string. So we're going to have three expressions here, right there, and let's do that. And it's going to print 200, makes sense. 55 makes sense. Let's actually evaluate this. 200 times 55, oh boy, that's 11,000. And add that to b times a. 55 times 200, that's also 11,000, so we get 22,000. So it looks like Java is doing a good job with the arithmetic. Obviously it will because it's a computer. So here's that's something that the power of Java gives us, is the freedom to put anything on the right side of that assignment operation. So let's actually talk about mixing literals in with variables. We talked about this with strings, and the same applies for integers as well. You can put anything in. You can do 10 plus a times b, and in fact, you can put it in the print as well. You can put print d times b, ignore that, and this, d times b plus 10. You can mix literals and variables as much as you want, as long as they are the same type. As long as the same type, you're fine. 10 is obviously an integer, and it's an integer literal. Remember how string literals are the ones with the quotes? Well, integer literals are just numbers. In this case, the literal here, the expression here that evaluates to a literal is stored inside this this variable a. So when you call an a, it goes here and it takes that integer literal and it prints that out. And as always, you can combine these in any sort of way you want. All right. So that's the end of this lesson. We'll talk about some primitive types in our next video. All right, welcome back to the third lesson, and this lesson is quite possibly the most important lesson so far because it talks about primitive types. And just from the name, you can guess what it sort of is. Type, obviously, we know that everything in Java has a type. We know that int is a type, string is a type, so we can declare variables based on those types. So we can int a equals 1, which declares an integer equal to 1. String b equals just a. So these two are examples of types, but only one of these is a primitive type, and that's the one highlighted in purple. It is a primitive type because it has a set amount of data storage, which means that when the computer takes the value of a, it puts it into a certain memory storage where it's limited. And that creates some sort of issue with regards to how big or small the number can be. And in this case, the integer can actually go from negative 2,147,483,648 all the way to the positive version of that, -1. So that's the range of the integer. And as you can probably guess, the integer is a primitive type, which means that it has a certain set amount of storage. We can declare another primitive type. Let's talk about a short. A short, just like the name suggests, is probably shorter than an integer. And this actually goes up to negative, let me put a comment here, negative 32,768 to 32,767. So this range is shorter than the integer range, but the advantage is that it takes up way less memory. Nowadays, obviously, you're not going to notice any difference between, 4 bytes and 8 bytes, but back in the day, these data types had to be used to conserve memory. But they're still quite useful. So you can put short y equals 32,100, and that's supported. But if you go 32,999, that's out of the range, and it'll tell you type mismatch cannot convert from integer to short because it's out of range of that short. And similarly, if you do something really big here, it's going to say the integer literal to whatever that number is out of range. So let's talk about some more primitive types that you'll likely encounter. Let's get rid of this warning. Whoops. Another primitive type that you may encounter is byte. Byte is even shorter than the short. It only goes up from negative 128 to 127. And let's talk about byte b equals 10. And let's fix these actually before, too many red lines appear. So byte b, like I said, once it goes out of range, you can't convert from integer to byte. And so let's change this back to 12. And as mentioned before, you can print any of these just with the variable a, print, y, we can print b, and all of them will print just like a string would. Let's try that out. And, ooh, there's an error. Oh, there's already let's get rid of this string actually. Clean up after ourselves. And let's launch it, and we're going to get 2 million. it looks like 329 and 12. And in fact, we can do any of our normal operations with this as well. And what happens when we do this is actually that everything here gets converted to an integer because that's the highest type. That's the largest type available. So it's going to add 2,329 and 12. And it's pretty obvious that if we added it and the type was short, it would be unable to add because obviously 2 million is bigger than 332,767 and it's bigger than 127. So we add these and it comes out in the integer type. And we'll see that right now. There we go. So it casts upward to the integer type. And casting is sort of a mixed bag. We'll talk about that a little bit later. But usually it'll do upward casting, which means that when you take a short and you add it with an integer, it's usually going to make the whole thing an integer. So that's what upward casting in a nutshell is. So we can print it, we can do all sorts of operations with it. However, if we have 2 bytes, for example, byte B is 120, for example. Oh, sorry, byte C, we already have byte B. And we try and add these, we may get into some problems. So let's try this. Oops, B plus C, and try that. Okay, now let's talk a little bit about the theory behind primitive types. So we just had a hands-on look at them, but let's talk about the reason why we prefer primitive types over some objects, for example. One of the most important reasons is because primitive types allow us to minimize space and maximize speed. Each of these elements has a specific, data size. For example, integer may be some 8 bytes, and all of these primitive types have a specific size, which makes them easier for the computer to handle. So using smaller numbers in a byte, for example, lessens the memory usage in terms of the compiler and what it needs to use. And so when you have programs with thousands, millions of data types and variables, you're going to run into a lot of memory issues, especially when you're running it on just your laptop. So primitive types conserve space and they occupy less memory, allowing for more speed because smaller elements require less time to travel from memory all the way to the CPU. And selecting the appropriate element type like short, integer, long, all that sort of stuff allows you and the computer to avoid taking up more space than really necessary. However, most of the time we do end up using integers instead of shorts and bytes because it's just more familiar to us in the real world. However, in this class, we'll try and use shorts, bytes, etc. as much as possible if we know what the value of the variable is going to be beforehand. And there's some other primitive types that we still haven't explored, like the character, the Boolean, and the double, which we'll take a look at a little bit later. They come in to play when we're dealing with decimals and more specifics with strings, as well as Boolean types and Boolean algebra. So we'll take a look at that a little bit later. But for now, that's all for primitive types. And the next week, we'll talk a little bit about integer rounding and integer division and all that sort of stuff. Thank you. Welcome back to the 4th lesson. This is a closer look at integers and really what goes on inside integers. You may have noticed from a couple of lessons ago that when we defined integer a as 10 and integer b as 20, and we actually did a print of the division between these two, that it returned something strange. And let's recap here. It just returns 0. Obviously, 10 divided by 20 is not 0, at least from a mathematical perspective. 10 divided by 20 is obviously 0.5, 1/2, 1/2, whatever you want to call it. Either way, 0 is not that. So something is going wrong here, and we need to figure out what. And this is where we'll get into decimals, because if you notice, 0, there's no decimals, 10, there's no decimals. Obviously, integer types don't deal with decimals. And when you do integer division, there has to be a way where it doesn't have a decimal. And when you divide these two numbers, it's 0.5, and even mathematical rounding, basic rounding, tells you that it should round to 1. But Java does this special kind of rounding called truncation, where it just cuts off every decimal, and that's how it does integer division. So if it does 10 divided by 20, obviously the result is 0.5. It just chops off everything to the right of the decimal place and it returns 0. Let's take a look at something, so another example of integer division. So let's try 10 divided by 30. This, even with our normal rounding, should display 0. 10 divided by 30 is 0.33 repeated, and that rounds to 0, and it also truncates to 0. But remember, truncation is what Java follows mainly for integer division. So let's change this to 2 divided by 3, and this should come out to 0.66666. But because of integer truncation, it cuts that out right to 0. So this is as simple as division can get. Divides the two numbers, cuts off everything after the decimal point, and that's it. Now, a lot of people don't prefer that. What if you actually want to know what 20 divided by 30 is? That's where another new type comes in, and that's the previously mentioned type, the double. And the double is similar to a lot of types in other programming languages, which is usually called the float. There's also a float in Java, but it behaves a little bit weirdly and a little bit differently. We'll use double for the most part. Double is a primitive type, which means that it has a set amount of storage, and doubles actually take up, doubles can take on decimal values. So let's talk about double C equals 10.5. Double D equals 10.6. So we've defined two doubles. These are double literals, which means that they're, literally doubles, just like things in quotations are literal strings, and pure numbers without any decimal places are integer literals. So with these double variables, we can do division with a lot more precision. So let's try that. Look at that. So we have 0.990566, all that stuff. And if you want to get out a calculator and verify this is correct, it will be correct. In fact, we can actually do C divided by A. We can do C, which is a double, divided by A, an integer. And remember, a couple of lessons ago, we introduced upward casting. In this case, double is a higher order, a higher type than integer. So this double will make this integer behave like a double as well. It's a little bit confusing, but you'll get used to it. So C divided by A will return a double. However, A divided by C will also return a double because there is a double in that expression. However, A divided by B will, like before, still return an integer because both of these arguments in between the division operator are integers. If you have one double in there, it's going to upward cast the integer into a double. So let's talk a little bit about upward casting. Upward casting is some sort of little mystical thing that we've been talking about. And it actually happens automatically. Back in the day when programming languages were just coming around, this used to not happen automatically and you would have to manually cast it. So let's talk a little bit about manual casting. If you want to do manual casting, you will have to put the name of the type, in this case, let's call it double, and you'll need to put the name of the variable. So this will cast the integer variable a into a double. Notice that this looks like you're multiplying double by a. That's essentially what you're doing. Let's try and print this out and see what happens. So int a equals 20, we're going to print double a, and it's going to print 20.0. This is manual casting, as opposed to automatic upward casting, which happened when we divided a by c. If you want to be safe, always manually cast. This is what I always do, and I recommend that you do it as well. Manually cast your integers into a double and divide it by another double. That way, there is no chance of a type mismatch ever. And it will be much more reliable for you as the programmer and for the reader as well, because he knows that A is not of type double if you're casting it. And he won't go up and change that to 20.0, which will result in an error. So let's talk about some more specifics we can do with casting. In fact, you can cast both things in an expression. You can cast double b. You can in fact cast something to be itself. So if we cast c, it's already a double. We can cast it again to be a double. Obviously, nothing is going to change because it's already a double. But we'll be able to know with absolute certainty that this will not fail. In any case, the double casting for a double is not required, but you can put it if you want, if you're quite paranoid. Another important thing with casting is that you can only cast upwards. For example, let's try and cast integer to this double. Welcome back. This week we're going to talk about a special type of primitive that is called a character. Now, a character sounds like a letter from a string, and it absolutely is. But there's one special thing about it, and that is that it is a primitive type, which means that it has a set amount of data storage, which means that it only supports a certain set of characters. So let's actually define a character, and just like any other primitive type, you get an abbreviated lowercase version. You type the name, the identifier, put the equal sign, and instead of putting the quotes, which makes it a string literal, we're going to put a single quote, which makes it a character literal. So we can define this as B, caps B, and that is our character. Let's define another character called, let's actually make these names a little bit better. First character, second character, let's set that to A. So you know that these two characters are right next to each other on the alphabet. They're both capital letters. They're both capital lettered, and A and B are obviously right next to each other. One special thing is that both of these are actually hidden integers. They're hidden integers in that they're essentially what we call magic numbers. Numbers are stored inside these characters, which actually represent the value of this character. Let me show you what I'm talking about. If we do integer, we define an integer called actual value, and we put in the value. We're going to cast it to an integer type, first char. And even if it's not required, I would suggest that you do it. In this case, it's probably not required. We can try it without and we can try it with, but I would suggest you put it in any case, just to make sure on exams, in programs, so that you're not bogged down with errors that are quite silly. Let's try it without and with, and we'll see. So it works fine without, because it's upward casting, but I would still suggest put it in there. And the special thing here is that it says 66. Why would it say 66? Well, if you look on the ASCII table, and let's introduce the ASCII table a little bit. The ASCII table, A is actually equivalent to, let's take a look, 65. So we're actually shifted up by 1, it looks like. And B is 66. And C is 67. So it actually looks like Java shifts these up for one reason or not. Perhaps it's the starting index of mine starts at 0 and theirs starts at 1. I'm not sure, but you can see that it prints out the decimal representation of the ASCII values for these characters. And we can try and test that even further by declaring another integer, next actual value, and setting that to the integer representation of second character, which is capital letter B, and print that out as well. And I would guess that this would be equal to 67. It's shifted up, but it's almost there. Or perhaps my ASCII table is incorrect. I'm not exactly sure. Oh, never mind, our ASCII table is correct. The first character was defined as B, which is 66, and that is correct. And A is defined as 65, and that comes out perfectly as well. So there was no misunderstanding. I just thought B and A were switched up and that first character was A, second character was B, but we were correct the whole time through. So it translates perfectly to the ASCII table, and that's a special thing about characters, is that you can check if two characters are the same just by comparing them with integers. So if these two integers are the same, then it's the same character. Let's try that. So if we define first character as A as well, and we run that, it will print the same number. And we'll actually get into Booleans in the next class, and we'll tell you how that works as well. Boolean is another type of primitive that we'll look at, and that will become very, very useful when we talk about conditionals and loops. Anyway, that's it about characters. They can be casted to integers, and in fact, why waste our energy on integers? We can actually cast them to shorts, because characters only have, you can actually cast them to bytes because they only have 127 variants. So let's try byte better value equals byte casting of first character, and we can print better value to save on some memory, like I said in the previous video. And look at that. We got the same number while saving some memory. I'll consider that a job well done, and we'll see you in the next video when we talk more about Booleans. Welcome back. Like I said, we were going to talk about Booleans, and Booleans they sound like a weird type, but they're possibly one of the most important types we're going to need to know, except for integers and strings. And like I said in the last video, they're used very, very often in ifs, which are conditionals, loops, like for loops, while loops, any sort of loop. They're used in do-while loops. And so the pillar of all of this is the Boolean primitive type. So in some languages, it's actually called bool, in Python, for example. But in Java, it's called the whole thing, Boolean, which is kind of strange because they chose to go with int for integer, char for character, and they decided to shorten everything except for Boolean, which is a little bit strange because it's quite a long word. Anyway, I digress. We can call Boolean, that's the type. Of course, we need the name. Here's our first Boolean, and we can set that to true. Now, true is a literal Boolean. A Boolean, literal Boolean, anything you want to call it. This just means that just like 2, 2.0, a, a. Let's review a little bit. That's an integer literal, that's a double literal, that is a character literal, and that is a string literal. So far those have been our main literal types, and let's add another one. Now we can do true or false. No caps, unlike in Python. We use caps in Python, but we don't in Java. And just like always, we can print out this type, and it's going to print out the string representation of our Boolean, which is going to be equal to true. Now let's just solidify this, do another Boolean, second Boolean, set it equal to false, print that as well. And remember, false is a literal Boolean. There we go. And we print that. True and false. Perfect. Now this is the simple part. This is the kind of boring part of Booleans. The really interesting part of Booleans is how you can compare them and the Boolean operators that come with it. So let's talk a little bit about the Boolean operators. So what you can actually do is compare two Booleans. And how we do that is, let's just start a new Boolean called calculating Booleans. And we can use our first Boolean, which is true. Intuitively, that should mean yes. For example, if I said, do you want to go to the store? The Boolean, if it was true, that would mean, yeah, I want to go to the store. If it's false, you don't want to go to the store. It sort of works like that intuitively. It's sort of binary, I want to do it or I don't want to do it kind of thing. It only takes two values. So you can do that and this. So this is our first Boolean operator, and it's the and operator, the ampersand, the double ampersand. This is actually the and operator. This means that both of these need to be true for this third variable to be true. Both our first Boolean and our second Boolean need to be true for our calculating Booleans to be true. And you can actually take a look at some of the modules on Boolean Algebra online to understand how this works in particular. But in general, we have several operators for Booleans. We even have an equality operator, for example. Is true equal to false, for example, we can try. And this is actually where we run into a little bit into some confusion. Because there is this equal sign and this equal sign, which is a bit strange, isn't it? It's a bit strange to see two types of equal signs. This one has one equal, this one has two. So in general, in most languages, the double equal sign is for equality and Booleans. So if you want to check for equality, this returns true or false. Obviously, our first Boolean is equal to true. Our second Boolean is equal to false. It's going to check is true equal to false. That's what this equal sign does. Is true equal to false? No. So it's going to return false. And that means calculating Booleans again is going to be false. And in a sense, the AND operator does the same thing. Only if both of these are true will it return true. If both these are false, it'll return false. If one of them is true and one of them is false, it's going to return false. So this is a sort of modified version of this. And both can be used for Boolean algebra. So now that we talked about doing some operations with Booleans, let's talk about what happens when you use this equality operator or the inequality operator and get a Boolean back without using Boolean specifically. Now that sounds a little bit complicated, but it really isn't. Let's define a Boolean called our new try. And let's check if 2 is equal to 3. Remember, very important distinction between this equals, which is the assignment operator. It assigns whatever's on the right to this new variable, and the Boolean equality operator, which checks if two things on each side are equal to each other. So this checks if 2 and 3 are equal, and obviously they're not, so it's going to return false. False, they are not equal. And this Boolean is going to be equal to false. We can try it the other ways, another way as well. There are other operators we can do. Our second try equals, is 2 not equal to 3? Yeah, it's not equal to 3, so it's going to return true. This is also a Boolean operator. It's going to return true, and so our second try is going to be equal to true. Last two operators we're going to introduce is the greater than and less than operator. So let's do our third try. Set that equal to 2 is less than 3. Is 2 less than 3? Of course it is. That'll be true. And the last one, our last try, is 2 greater than 3. Of course not. That's going to be false. So let's print all of these in a row, and we'll use some copy pasting here because I don't want to type all of these print statements. Here's one. We'll paste a couple of them. Calculating booleans again. Here is our new try, our second try, our third try, and our last try. Here we go, and let's run it. Praying for no errors, and there aren't any. Ooh, that's a lot of stuff. So the first thing, calculating booleans, was true. Let's take a look. Our first boolean and our second boolean. And then the second thing was, the first thing was our first boolean, which was true. Our second boolean was false. The third thing we printed was calculating booleans, which is our first boolean and our second boolean, which is false because true and false is false as per Boolean algebra. Next thing is also false because they're not equal. Our first boolean is true, our second boolean is false. Calculating booleans, our new try is 2 equal to 3, obviously not, that's false. Is 2 not equal to 3, that is true. Is 2 less than 3, that is true, and is 2 greater than 3, that is false. So we got back everything that we expected. We got a new primitive type to try out, which is the Boolean type, and most of the time we're not going to be using Booleans to compare with each other. This tends to not happen as much. This happens a lot more, especially in conditionals and in loops. Ways of attempting Boolean algebra in Java. So we already introduced one of the main operators, which is the AND operator. And for the purposes of this video, I'll very briefly explain what Boolean algebra is, but we'll talk more about how Java uses Boolean algebra rather than Boolean algebra itself. The AND operator, the OR operator looks like a double pipe. That's the OR operator. And the NOT operator is the exclamation. And obviously we've already introduced the equality operator and the inequality operator, which means that are these two things on each side equal to each other. We've talked about the less than and the greater than, less than, greater than. And in fact, we have the less than or equal to, less than or equal to and greater than or equal to, right here as well. Less than, equal to, greater than or equal to. Okay, let's try these out. So let's define a Boolean A as true, and this is following the usual Boolean algebra syntax where we have A and B. Boolean B equals false like we did before. Let's try Boolean C equals true as well. So let's do a bunch of prints, and as usual you can do expressions in the print. That's completely fine. Let's try A and B.
Let's try A or B. And A equals B. And lastly, let's try a compound expression, which is a bunch of stuff. A and B, or C and A. How about that? Okay, now A and B. Let's talk about the AND operator for just a little bit and how it works in Boolean algebra. Essentially, only if both things are true will the AND operator return true. Let's give quite an easy example. Let's say you're really greedy one day and you really want to eat pizza and ice cream. Suppose A represents whether you get pizza and B represents whether you get ice cream. And you'll be only happy if you get pizza and ice cream. That's why you're greedy. So this will only return true if you get pizza and you get ice cream. Otherwise, you're not happy and it's going to return false. That's essentially how the AND operator works. Only if you get both things to be true can the AND operator return true. Otherwise, you're not happy and it returns false. The OR operator is a little bit different. Let's assume again that A is whether you get ice cream and B is whether you get pizza. But this time you've set your hopes a little bit lower. So you're okay with just, having pizza or ice cream. In this case, if you get one of these, you're happy. If you get pizza, it's going to return true. If you get ice cream, it's going to return true. If you get both, you're even happier, it's going to return true. If you get none, then you're going to be a little bit angry. Then you're going to return false. So if you get one or both, you're going to return true in terms of the OR operator. This obviously is an equality operator. It checks whether A is equal to B. Is true equal to false? I don't think so. This will return false. This will return, it'll return false. The last thing is a little bit more complicated, and this kind of requires a little bit more knowledge of Boolean algebra beforehand, but I'll try and explain it as succinctly as possible. Essentially, the order of operations in Boolean algebra states that AND comes first, which means that pretend these are multiplications and this is addition, for example. We would do our multiplication first, which means that this has higher precedence in terms of evaluation. So we do A and B first, which is false. We did that here. C and A, which is true because they're both true. You get ice cream and pizza, so you're very happy. And then you have what this evaluated to, which is false, or what this evaluated to, which is true. So you get false or true. And of course, if you get one of them to be true, the OR operator returns true. Now that may seem like a lot to deal with, and it certainly is if you don't know Boolean algebra, but play with it in Java. It's quite intuitive in Java as well. Learn the order of operations. It tends to be not first, and then and then OR. So OR is the least, has the least precedence, and not has the greatest precedence. And actually, that reminds me, we haven't tried out not yet, so let's try that out. Let's try not A. Just not A. And then let's try not B. Perfect. So let's actually run this and see what happens. And just after that, we'll talk about what the difference is between these operators. All right, we got a bunch of output. A and B, we said that was false, and it comes out to false. A or B, you're happy with one, so it's true. A equals B, obviously it's going to be false because true is not equal to false. This compound expression, we said just before that it would come out to true, and it does. And not of A is obviously equal to true, false, and not of B is obviously equal to true. And we got quite a nice pattern: false, true, false, true, false, true. Okay, before we move on and jump to the next topic, which is actually an introduction to a special type, a very, very special type, let's talk about the difference between these operators. You'll notice that some of these operators have two things on each side, and some of these have just one thing. Well, this exclamation, which is the not operator, is a unary operator, which means that it is It only takes one argument. So when you take the not of something, for a Boolean, not of true is obviously just false. Not of false is equal to true. There's only one thing you can really process, so it's called a unary operator. This, the AND operator, the OR operator, the equality, the inequality, the greater than, less than, whatever it is called a binary operator because it takes two arguments. This takes A and B, so it's binary. Binary means two. And so that's basically a difference between these two. And let's move on to a different section of Boolean algebra, which is not directly using Booleans, but returning a Boolean result. So for example, we did this in the last class. Is 2 equal to 3? Obviously it's not. It's going to return false. Similarly, is 2 less than 3? Yes, it is. It's going to return true. Let's introduce the new one in this video, which is, let's put the print line here, which is the equal to, less than or equal to. So is 3 less than or equal to 3? Absolutely. Is 4 greater than or equal to 4? Absolutely it is. So these 4 should just return true. No. This should return false, this should return true, and this should return true, and this should return true. So let's actually get rid of this for now. In fact, yeah, let's just get rid of it for now. And print this, and it should print false, true, true, true. And that's exactly what happened. All right, let's bring that back. And just as a quick reminder, you can absolutely use Boolean variables and Boolean literals in the same expression. This 2 equals 3 is a Boolean expression which evaluates to false, correct? And then you take that Boolean literal false and you can evaluate it with, A, or you can evaluate it with B. You can evaluate this with B, or the not of B. And so just like integers and doubles and all that sort of stuff, you can mix and match Boolean variables, Boolean literals, and yeah. So these things basically lay the foundation for loops and conditionals, which we'll get to very quickly. Bye. All right, so before we get into what the meat of what Java is about, which is classes and objects and the concepts related to that, like inheritance, encapsulation, polymorphism, all that sort of stuff, we have to introduce one last main data type that we're going to use, and that is the array. And for now, we will focus only on the integer array and the string array. So let's talk about how to declare an array. First, you start with the type of the array. So if we're going to put only integers in the array, we put only integers and we type in int. If we're going to put strings in there, we type in string. But we're going to start with integer. Then we put 2 braces. Once you put the first one, Eclipse fills out the rest for you. You put the braces and then you put the name of your array. Name of array. You can call this anything you want. I'm just calling it name of array to make it easier to replicate. And then after this, we get a special syntax. And it's a special syntax, which is a little bit strange because it's not like the primitive syntax, and it's not completely like the object syntax, which we'll get to in the next video. This syntax is a little bit different because it starts with the word new, which we'll see in the object syntax, and then you type in int, but you put in braces the size of the array. So let's go over that. This is the type, integer array. That's the name of the array. We instantiate a new object, and that object type is going to be an array, integer array of size 10. So it makes that object of size 10, and it shoves it in to this. And we'll talk a little bit in this video about what the differences are mainly between how we declared this and how primitive types are declared and how they behave a little bit. But we'll explore them a lot more when we get to the meat of this course, which is obviously in objects and classes, because obviously Java is an object-oriented language. So we've declared an array. This array is going to be empty because obviously we haven't put anything in it. But the main way we can modify arrays, since it's empty, we want to put something in it, right? Is through index notation. Index notation is something where you refer to a particular spot in that array. And for those who don't know exactly what an array is, it's just a list of numbers. And an array could look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This has a length of 10, by the way. So if we want to put this inside this array, we could. It can look like just a single element. It can be empty. But essentially, it tends to be a list of certain things. And in this case, it's a list of integers. So let's talk more about how we put things into the array. So what we do is we put the name of the array. We put these braces, which seem to show up a lot when we talk about arrays. And then we put the number of the index inside this. And that gets a little bit confusing for some non-CS people because of the weird way indices are defined in computer science. They start with 0. So if you notice here, I'm labeling the indices up top for the array down below. If this is the array, 1 is in the 0th index, 2 is in the 1st index, 3 is in the 2nd index, and etc. So if we want to access the number 4, we have to talk about index 3. So that's how we do index notation. And then we can set that to whatever we want. So let's set that to 4. So we've edited that part. We need a semicolon. And in fact, we can edit every single one of these indices to reflect this array right here. So we're basically just trying to recreate this. So let's try this. Whoops, missed our semicolon again. And just for speeding things up, we're going to copy paste a little bit. So this variable, this one's going to be number 2, number 3 is number 4, index 4 is going to be equal to 5, index 5 is equal to 6, index 6 is equal to 7, index 7 is equal to 8, and index 8 is equal to 9. Index 9 is equal to 10. Now, you'll notice just from the basics of arrays that this gets kind of repetitive, right? We go from 0 all the way to 9, we go from 1 all the way to 10, and you'll notice that every time our index number and our number that we're going to put in the array is 1 off. And this pattern is very obvious. So much to the point that we really should be making this a lot easier on us. Instead of copy pasting, we could just, do something different and make this a lot quicker than it currently is. And we'll get to how we can do that through loops in once we get to classes and objects. So we've filled up this array with 1 through 10, and this is what the array looks like. Unfortunately, with Java, it's not as easy to print out arrays, so you'll see when we print this array out, we'll get some weird symbols, and that's because it's an object. So let's try that. And that's quite a weird symbol because it's an object, and objects don't print as well as literals unless you define a special method, which arrays don't have. Arrays don't have methods, they simply have their special objects which only have index notation. So we can't print out the array directly unless we call on a library method from the arrays package, but let's leave that to a later time because we haven't talked about packages and classes yet. So we'll actually just have to call on these separately. And in the name of not wasting time, we're going to copy paste, and we're going to print only the first couple of elements. So we got 1, 2, 3, 4. Perfect. And I'm sure you believe that the rest of it is also in there. Like I said before, array is a type of object, so it's not a primitive type. It doesn't have a set amount of space. Well, technically, it could, depending on the size of this. Obviously, I can change this to 100, and the size of the array would change. But it definitely does not behave like a primitive type, and we'll see that in later when we introduce objects and classes. So this is a basic intro to arrays. We can do something similar with strings, same sort of syntax, array2, new string, the size of the array. Let's just do 1 for this time. That means that you only have one thing you can put in the array, which means that it has to be index 0. It has to be a string, so you can set that to, I don't know, high. And if you want, you can print that out. There we go. Run that, and it should print out what's in the 0th element of that string array, which is high. This may not seem as useful now because we're literally just putting things in arrays and just printing them back, but there's a lot of applications for arrays. It's a very efficient way to store a lot of data. For example, let's get rid of all of this. If we have 20 integers, int a equals 10, int b equals 20, etc., all the way to int z equals 100, now that's going to be a lot of lines. And even if you want to do it another way, which is possibly more efficient, it's another way of assigning primitive types. You can do a equals 10, b equals 20. Even if you do it that way, it gets quite long. Instead, if you put it in an array, it's a lot easier to access, a lot easier to modify, and a lot easier to work with. So that's some of the logic behind why arrays are used. And obviously these are redeclarations of the same variable. It's a duplicate. Let's rename A to A1 and B to B1. But yeah, that's just a quick introduction to lists. We'll obviously talk about lists as it relates to being an object a little bit later when we talk about objects in the next video. See you later. Alright, welcome back to the 6th lesson, and this lesson is probably the most important lesson in Java as a whole. This deals with the basics of classes and objects and these sorts of modifiers here. So the first thing is obviously defining what an object is. And an object is just sort of a real-life object. There's really no better way to define an object other than that it's an object. For example, a pencil is an object in real life, and it can also be an object in Java. You can just create a pencil in Java. However, you need to have defined what a pencil is to create it, and that's what a class is. You're defining what an object can be. Essentially, you're creating a blueprint for what the object is using Java. So for example, I've called this class animal. So this is a blueprint for how to make an animal object. Suppose we wanted to make an animal object named Joe. We could make an animal object named Joe just like this. It was new animal. And this would create an animal object. However, this is the class that creates this new animal object. And when I did this, I created the new animal object right here. But before we get into the syntax of creating and instantiating objects, let's talk more about what the specifics of the relationship between a class and an object is. For example, an object is created from a recipe. A food you can create from a recipe, right? So for example, say we're making pizza. We can create pizza from dough and cheese and tomatoes and all that sort of stuff. And we have steps to do it. Like first you take out the dough, first, second you do this, all that sort of stuff. That recipe, that blueprint for making a pizza is the same sort of thing that you would do in creating an object. And that is what represents the class perfectly. A class is sort of just a recipe for how to create objects. And for example, this class is called animal. So with this, we can create as many animal objects as we want, and this class is a blueprint for it. Now let's move on to two types of relationships that we have in Java and most programming languages that are object-oriented. That's the is a and has a relationship. Has a relationship is quite easy, and that just defines what an animal really has. For example, an animal has a run speed. An animal has a walking speed. An animal has a color, a weight, eye color, all that sort of stuff. So all these things go into what an animal has. And these are attributes that the animal has. And we can define these through Java. So we can say the run speed is, 10 miles per hour. Walking speed is 5. Color is brown, weight is 400, and the eye color is brown as well. So these things are what go into a has a relationship between an object and a class. The is a relationship we'll hold off until a little bit, but it essentially represents when some particular type is an example of another type. So for example, a horse is an example of an animal. And with special tools in Java, we can create that sort of relationship as well. And that is actually called inheritance. We'll look at that in a little bit. Let's actually change this from animal to car. And it's going to complain, obviously, because the name of the file is not car. Let's rename it to car. We can actually define, for example, car speed, color, make, model, all that sort of stuff. And actually, we won't do that now because this is somewhat of a theoretical lesson in how the class-object relationship works, but this is very easily doable. The next thing we're going to discuss is the modifiers. You see public in front of everything. Except for everything in the main method, you see public in front of everything. You see these weird purple things. These are actually what we call the method signature. And we talked about this in the first video that we did coding very briefly. This says public static void main string args. We're going to leave off on static for now, but if you're really curious, it basically means that it's not associated with a particular object. Public is probably what we're going to focus on right now. Public just means any class, any object can see this method. If we declare this as a private class, no other class can see it. And Java obviously doesn't like that because that would make the whole class useless. You saw a couple of types of classes there as well, some like abstract class, and those are actually even more blueprinty versions of classes. We'll talk about those a little bit later as well. So these modifiers like void, which mean that the method returns no type, work to ensure that Java knows exactly what it's getting into when it executes the program. Okay. There are two types of very simple methods that we can have in a class. And before we talk about those, let's talk about what a method is. A method is just a particular sub-recipe we have inside the object. So for example, if we want to make our animal, or our car actually in this case, run, well, go for a couple of 100 meters or something, we would say car.go, the name of the car, sorry, .go, and then we would specify the number of meters we want it to go. And that in itself is a method. It's telling the car object to do something. Instead of has a relationship, it's telling the car to perform a certain action. And in a lot of languages, it's called a function, but in object-oriented programming, it's called a method. The way we declare a method is we write the public modifier first. Let's leave off the static modifier. We'll leave that till later. And we put the return type second. So the return type for now, let's say it's an integer. And we'll talk about a little bit more about what a return type is. Well, we want to call it something, so let's call it go. And here, we're actually going to specify some parameters, which means that what this method takes as an argument. So remember how, for example, the print argument takes whatever you want to print in it, for example, hi. In that same sense, go takes a particular argument, and it's going to take an argument, say, distance. We do our braces, curly braces, and there we go. And it's getting mad at us because we haven't returned anything yet, but we will. So this is a basic method signature. The method goes inside the class and it defines something that an object can do. That's essentially what a method is. And this method is designed so that it makes the car go a certain distance. So let's make this really easy. And when you type in a distance that you want it to go, it's going to just say return. Actually, let's make this a string. Car went a distance of, and we'll use string concatenation with the distance, and there we go. So we talk about a distance as a parameter. We get the distance, and then we return a string that says that the car went a particular distance. That's a very simple method. Now, that's our first example of a method, but there are specific types of really simple methods that you could implement as well, such as accessor methods and modifier methods. Or mutators, you can call them mutators as well. So these deal with the has a relationships. So we'll hold off on these for a little bit, but they usually tend to be defined like this. Public, we can make this any type, for example, int, get distance, and this would return our distance. This would be a accessor method. We're accessing a particular has a relationship and we're getting it. We're getting that car's distance. If we want to edit something, it tends to be like this: set make, make equals this dot make equals Toyota, for example. Sorry. It would be defined like this, where we are given a particular value to set it to, and we set it to that. So these are two types of methods, and I'm just giving you a quick preview here. You may not understand a lot of this accessor method, but let's go through it and see if we can make some sense out of it. This one is a little bit easier. It's very similar to this one in that it's a public method with no parameters, which means that when you call on it, you would put nothing in it, something like that, except it would be with the object, a car object, and then you would return the distance that it's traveled. And in fact, this should have a this dot distance to it. But in the most basic sense, ignore the this dot notation, but in the most basic sense, this gets a particular value, and this sets a particular value. Notice how this is an assignment operator which sets this dot make into as make. And this notation here may not make a lot of sense, but both accessor and modifier methods are quite widely used to modify the has a relationships in a particular class. Another very important thing about classes is the concept of encapsulation. And encapsulation in a lot of programming languages is a little bit different from what Java makes it out to be, in that Java thinks that encapsulation is a sort of protection. It's a sort of way of hiding data from users. Encapsulation is essentially making data private so that people can't see what it is. And the sort of reason behind that is that sometimes you want classes to be protected against people changing it, people changing values. Like, for example, if our car registration numbers are very important and private to us, and that they can only be delivered via an encrypted message or some sort of code, I would make the registration number private. Obviously, I haven't defined it and I haven't told you the syntax for it, but there are ways to make it private, and that would encapsulate the data that is the registration. And now the car has a relationship with the registration number, and that represents encapsulation as a whole. There are some particular theoretical topics that we haven't covered, like the static modifier, and we'll cover that in the next video. See you later. Welcome back. So we are going to cover a little bit about what static methods are and what they can be used for. Essentially, theoretically, static methods are not associated with objects at all. And let me talk a little bit about what that means. That essentially means that whenever you talk about a particular car, let's actually instantiate a car first. And the way we do that is obviously type first, name of the car second. So let's actually call our car our first car instead of a name of the make. And we want to have the new keyword, meaning that it's going to create a new object, and it's going to be a car object. These two things, these two parentheses here, are a notation that calls a constructor of a particular class. We'll look at that in upcoming videos, but for now, just accept this as the creator of an object. This instantiates a new object and puts it into the label our first car. So we have a car named our first car. Now, our first car can undergo some methods. It has particular properties. For example, it has car speed, color, make, model, has a registration number. Now, it doesn't have all of that literally because we haven't defined it. It only has a go method that we briefly defined last time. But let's actually set and try out this new method, the go method. And once you type in go, it comes up with a dialog box where you can see that the only thing defined for this particular object is this method. And so we want to put an integer in here, and it tells us exactly that. So let's put 10. Now, let's think about what this would do. We took our new object, and we have this dot notation, which means that we're going to make this object, the one that we have defined, go 10. We're not making any car go 10 meters. We're making this car go 10 meters. And we'll differentiate that from our second car, which is also going to be a new car. This is a completely different car. And if we do our second car.go 10, that's a completely different car, and it's going completely differently as compared to this first car. So both of these operate on different objects, and they're completely different. Don't get confused between these two because these are instance methods. And instance methods don't have a static keyword here, and they mean that they're attached to a particular object. So this go method operates on this object specifically. This go method operates on this second car specifically. And in fact, if we had an attribute here, let's actually define our first attribute here. Private string, private int distance. So we've defined an integer called distance, and it's private, which means that it's encapsulated. So we've defined a distance, and in fact, let's change the implementation of this method so that it returns an integer. And in fact, let's actually make this distance, yeah, it's just complaining because we haven't returned anything, named dist, so we don't get confused between the two distances. So what we need to do is we need to add on to distance. So we're going to do distance equals distance plus dist, and then we will return, and we'll notice the red after a little bit, and we'll talk about some other syntax that we can use. Return distance. So this may be confusing, but this distance refers to that distance right there. This is an attribute of the class. This is a has a relationship. Remember how we talked about the color of the car, the make of the car? This is something like that. This is something associated with a particular object. For example, this object has a particular distance. This object has a different distance. These are instance attributes specific to an object. Notice that the reason I'm saying that is because they don't have static keywords. That means it's an instance object. This is a distance we specify, and then that distance gets added on to the current distance. So let's pretend our distance is 0 first to start with. And we can do that right here. Private int distance equals 0. This is bad programming practice, but let's just keep it for now because we haven't explored what constructors are yet. So suppose we have our distance 0 and we do .go 10. Our integer distance, our argument here, is 10. We pass in 10, just like if we passed in a print. The print method is taking in whatever we passed in. Like for example, this string high. It's taking in this string high. In this case, it's taking in this string, the integer 10. It's adding it to the current distance, and it's setting distance as equal to the sum of the previous distance and the new distance. Essentially, if you set 10, it'll be 0 plus 10 is 10, and so distance will be 10, and it will return that value to the user. Okay, I'm just going to give you a moment to breathe that in. Essentially, this will return our current distance. It's going to be sort of like an odometer. I think that's what it's called. Of how far the car has gone. And we can do it consecutive times as well. We can do car.go 20, for example. Let's ignore our second car for now. So this will return 10, and then after that, it's already traveled 10. It has an attribute that is now equal to 10. Now it'll travel 20 more. So 10 plus 20 is 30. And now the distance is 30, and it will return that. Okay, let's try it out and see what happens. And actually, we need to print this out. So since it returns an int, this will return an int, so we need to capture that integer. So let's actually just print it out instead of storing it in an integer variable. So let's print that out. Let's also print this one out. Okay, print that, and there we go. Hi, we had that from before, ignore that. But the first time we call the method, we say we want to go 10. We pass in 10 as an argument, and then it takes that 10 and it adds it to the current distance, which was 0. Remember, we just defined it. So the normal default distance is 0. It sets it to 10 now, and it returns that back. Once it returns that back, it's printed, and it says 10. Now we take our current distance and we go 20 more. So our argument is going to be 20. Our current distance is 10. 10 plus 20 is 30. Distance is now equal to 30. It returns that back, and now our distance gone is 30. Now, quite self-explanatory, if we go 100 more, it's going to say probably 130 because we've gone 30, we go 100 more, and then now it's going to say 130. Okay, let's explain how this is different from another car. For example, let's say we have our second car. We introduced that back into the fold. We declare our second car. Our second car is a new car. It's completely different from our old car. This car has no distance on it. Its distance is currently 0. And we can see that if we actually just print out our first car dot go 0. So if we go as distance of 0, it's just going to add on 0 to that, and it's going to return 0. And we'll see that right here. Oh, sorry. We forgot to replace our first car with our second car. I was confused for a second. Alright, this should say 0 now. There we go. It says 0 because we've gone no distance. This instance of a class, which is this object, is a completely separate entity from this class, this object. Our first car is different, our second car is different, and with instance variables and instance methods, you're operating on simply that one object, just that one object. Okay. So now let's modify this object a little bit by changing its parameters. Changing its attributes. Let's say we want to go, I don't know, 10. So now this one's gone 10, and this one's still gone 130. Let's try it out. This one's gone 130, and this one's gone 10. So it's all working out. So we've introduced an instance attribute and an instance method, both of which operate on separate objects. It operates on the object and doesn't have anything to do with the class. Now let's talk about statics. Statics are a little bit weird in the sense that static means that it applies to all the objects. So for example, let's pretend that our car has a particular number of wheels. So num wheels equals 4. And let's make this public just so we can access it. Okay, let's talk about how this is different. This applies to every instance of car. This applies to every instance of car. Let's play around with this and see what we can do as compared to any other instance attribute. And you'll notice that I changed this to public, and that's usually tends to be bad programming practice, but we'll do this just to explore what statics can do as opposed to instance attributes. So let's try our first car. Suppose our first car breaks down. Let's say we break off a wheel. This is kind of morbid, but let's pretend that the number of wheels changes to 3. Now notice, we use the same dot notation, except without the parentheses. When we do the dot notation with parentheses at the end of the name, it's a method. When we do it without the parentheses, it is an attribute. And in fact, we can actually try putting distance here, but there will be a particular error that you'll see. Sorry, there won't be an error, but that tends to be bad programming practice because it's a private attribute. So for now let's just stick to number of wheels, and we'll modify that to 3. Let's suppose one of our wheels broke off, and so now we can print out the number of wheels we have on our first car. Caps there. Oops. And again, we can access this because it's private. So now we have 3 wheels. Let's see what we have for our second car. Let's try that out. Uh-oh. Our second car is only 3 wheels as well. This means that when we broke off a wheel from our first car because of an accident, we also broke the wheel from our second car, which is not good. In that sense, static attributes apply to every instance of the class, every object that is created, whereas instance attributes can change between objects. The distance, which is not a static attribute, it's an instance attribute, is different for both these cars, except the number of wheels that both cars have will always be the same. It'll always be the same. And if we change it for one, it changes it for all of them. And it's a double-edged sword in the sense that if you want something to be a global property, like for example, most cars tend to have 4 wheels, they don't tend to have 3 wheels, we could set this as a static property. And we would be safe in doing so unless obviously we take this example of the accident. But something that's global, something that's usually always true, can be defined as static. Otherwise, if it changes between instances of the class, if it changes between objects, it has to be an instance attribute. Alright, so that's our in-depth look at what differentiates between static attributes and instance attributes. We'll take a look at static methods a little bit later. But for now, make sure that anything that should be particular to an object is declared as an instance attribute, and anything that's global should be a static attribute. And that rounds out our lesson on that. See you. Hi, welcome back. So you might have noticed that we changed setups a little bit for this video. And that's because I want to show you what bare bones Java looks like. We've looked at stuff from Eclipse, the IDE that we were using previously, but now I really want you guys to get involved with what Java really does behind the scenes, at least to a degree. We're not obviously going to go in and compile the code like, flip all the bits and all that sort of stuff. But I want you guys to see how Java works from the command line, which will be very important for all you coders, and future programmers. You're going to need to know how to do that. But for now, let's talk about something called inheritance. Inheritance is very special in Java, and it has a special connotation because it's one of the most fundamental fundamental concepts in Java. And that is because it is based in object-oriented programming, which is what Java is really about. So we recently talked about static methods and instance methods and all that sort of stuff. Well, this fits in quite nicely because, as you can see, I have 2 classes here. And for now, let's avoid the signature of the class, which is public or private. Let's ignore the access type for that class. Let's just look at what the class means. So we have a public class up here called inheritance. We're going to ignore that for now. We have a class called animal. And this is just a class that describes any animal, right? Any generic animal. So that could be a dog, a cat, a mouse, really anything, right? Animals can have, 4 legs, 2 legs, 8 legs, 3, I don't know if there are animals with 3 legs, but, and then we have a horse. Horses are pretty specific, right? Horses have 4 legs, they're pretty fast, they're usually brown, they can be black, so they're a lot more specific than the animal. However, animals and horses share a lot of traits. More specifically, the horse inherits a lot of traits from the animal. For example, a lot of animals have eyes, so this would inherit that. A lot of animals have legs. The horse class would inherit that. So to make implementations of our class a lot easier, we would inherit traits from previous classes to make it easier on the coder and to make code more precise and compact. So what we would actually do here is make this a subclass of animal by writing extends animal in the class signature. This means that everything inside of A, besides the constructor, is inherited from animal. And I'll talk a little bit about the specifics of the constructor a little bit later. So suppose we had something in here that said private Boolean has eyes. So this means this would store a variable associated with whether the animal has eyes or not. And just for just for the sake of finishing our program here, let's have a constructor for animal which takes in one variable, Boolean has eyes, and as usual we will refer to all our instance variables with the this keyword, and all our local variables without the this keyword. So this now has a constructor. However, since this is a private variable, our horse cannot access this variable. So let's create an accessor method for this. So the accessor method is just going to be a way for any client meaning anything that uses this class, to access the private instance variables of this class. So let's do a public method here because we obviously want people to access it. And this is going to return a Boolean type. And it should be called getEyes. And inside it, we're going to return the value of has eyes. And as usual, we're going to refer to our instance variables with the keyword this, even though it's not required. This is actually a more so of a Python convention where you have to call it by, in that case, self, in this case, this, using that keyword, but it's not required in Java, but I would suggest doing it just in case you have other local variables or other variables and other scopes that have the same name. So we have our accessor method that gets the value of a private instance variable. We have a constructor and we have a instance variable that describes whether the animal has eyes. Now, I know for all you biologists out there, this is probably not a great way to explain animals and horses and inheriting features, but just bear with me. I'm not a biologist. So here, what we can actually do is we don't need to know if the horse has eyes. The horse naturally has eyes. So what we're actually going to do is we're going to call the super constructor. So let's try this. Let's try implementing a constructor for the horse, and this also takes in a Boolean has eyes. Sorry, it doesn't take a Boolean called has eyes because we know horses have eyes. And what it would call is something very special here, and I want you guys to pay attention. This will call super true. Now let's explain this for a second. So the first thing we want to notice is that animal may or may not have eyes, and that depends on this argument here, the argument to the constructor. However, a horse we do know definitely has eyes. And how we call a constructor is using either super, which calls the superclass's constructor, which calls whatever it extends constructor, or this. This would call the horse constructor. So obviously we don't want to just keep calling the horse constructor. We want to call the animal constructor and pass it the value true, so we know that the animal has eyes. So in this way we can actually use the constructor for animal to make sure the horse that we're talking about has eyes. And just for reference, let me just write up here, this is the superclass, the class that is above the subclass, and this is the subclass. The subclass inherits properties from the superclass. The superclass does not inherit properties of the subclass. So let's actually get rid of this comment here. So now what our horse constructor does is it grabs the animal constructor and passes in true and creates an animal that has eyes. However, we really can't access those eyes, right? But that's why we've implemented public Boolean getEyes. So in case we call getEyes here, it'll go right up here and it'll find the method. So let's try that. Let's get rid of all this blank space here, and let's go up to our main method. And remember, only one main method executes each time we run something, and that main method is going to be the public class. So we can make as many non-public classes as we want, just as long as there's one public class uh, whose name of the file it is to be put inside the file that contains the class. Okay, that was a little bit complicated. What I'm saying is you need a file named something.java, and that something needs to be the name of the public class. That's better. Okay, so let's actually create a new horse called little horse. Put it in camel case, new horse, and we can call it, actually we can't call it anything. Let's add that implementation a little bit later. And then we can actually print this little horse's eyes, whether it has eyes. It should. If we've done this correctly, it should 100% have eyes. Let's check it out. So as usual, we're going to compile first. So that means that we have to do Java C, and it's actually quite easy nowadays to use Java C in Java. So you do Java C inheritance.java, and then you just run Java inheritance, and it should return true. And it does, because we've implemented it correctly. Now let's think about this a little bit. So if we have our horse, and we make a new horse object to put inside the type horse, can we have an animal? Sorry, animal, not animal. Can we have an animal that's also a horse? That's a good question. Let's actually try it out and we'll see what happens. As usual, we're going to compile again. And this is one of the main reasons people don't tend to compile and interpret manually, is because this process is kind of burdening when you have too many files to compile. You have to run javac, all the Java files, and all that sort of stuff. The IDE takes care of that, which is a lot better. But it's also important to know how to be able to do it in the case that you need to do it. So let's try this out. And it returns true. So in fact, we can actually have an animal of type horse. Sorry, a horse of type animal, and it has a little horse object inside of it. And this is the crux of inheritance, is that a subclass can be contained inside a superclass. And the key word we use to describe this is actually a horse is a animal. That's the is a relationship that I've been talking about so far. So now that we figured that out, that concludes our inheritance video for now. And I'll see you guys a little bit later in our next inheritance video. Thank you. Okay, welcome back. So we're actually going to experiment a little bit with inheritance right now. And we talked a little bit about how it worked last time, but let's really discuss the behaviors of what inherited objects, or in other words, superclasses and subclasses, interact. So we have the same horse class and the animal class that we had earlier. Just to reiterate, the animal is the superclass, which means that it has all the properties that is general to an animal, and the horse has a specific implementation of an animal. So for example, an animal may or may not have eyes. So this should actually be private. An animal takes in whether the animal constructor takes in whether the animal has eyes or not. But we know for a fact that horses do have eyes. So we pass in a true value for has eyes to the superclass's constructor. So in that sense, it's a more detailed implementation of the more generalized superclass. That is the subclass. Okay, so let's discuss, to reiterate again, what this line here means. This line is essentially assigning the new instantiated horse object to type animal. And we can do that with inherited objects. So suppose a superclass of this horse is mammal. We would also be able to set this to mammal because a horse is a mammal. For example, let's suppose we had another class called four-legged. if four-legged was a class and horse extended that class, it could be of type four-legged, even though a horse is a horse. This determines what the object truly is. This is simply the type of the object. So for now, we'll keep this as animal because we haven't described any other classes besides animal for it to extend. And let's talk a little bit about what we can do to experiment here. So let's actually make the getEyes function come to the horse class and see what happens. Let's try this. So we get rid of this and let's paste it over here. So now what we've done is, whoops, we've taken a method, an instance method from the superclass, and we've put it here. And let's see what this actually does. And I want you guys to predict it as well before we do this. So let's compile. Ooh, we had some issues here. Let's see. So first issue here is that it can't find symbol. Okay, so which symbol can it find? The method getEyes. Now since this is of type animal, it's going to look in the class animal for getEyes. And since it doesn't find it, well, it can't really do much. So that's the first error, is that it can't find this instance method in type animal. Now, the second error is that hasEyes has private access in animal. So if we take a look at our code again, we'll see that Java has actually upheld its vow to keep private variables private, and it has errored. Since this cannot access private variables or private methods, this has not been able to access the variable of hasEyes that's in animal. So let's get rid of this and put this back where it really belongs. Up here, whoops, woo, what happened? Whoops, we just went to the end of the document. That was my bad. So let's paste this back where it belongs. And let's make this private. Ooh, let's try that. And we'll actually also get rid of this. Alright, so now our class is back to normal, except we changed one public to private. So let's try this. Ooh, look at that. So that also errors. And the reason for that is that getEyes has only private access in animal. So a horse object cannot getEyes if it is made private. So this can't access this method since it's of type, it's a horse object. And it cannot be called either because we're in a different class. We're in the inheritance class, and so it cannot be called. Now suppose that this was in here. Let me paste this here. And this was made the public class, then it would be fine. And let's talk about why. Let's try it. We actually need to change our file name to animal.java to do this. Let's run the compiler. Look at that, it runs fine. And we'll run animal and it works fine. But so what changed? Well, this is what changed. When we run getEyes from here, we know that getEyes is a private method. So it is consigned to only be accessed in the class that it was defined in. Now this private method was defined in animal, so anything in animal, and this is an animal, can access it. And so that's why the little horse, which is of type animal, could access the getEyes function. Now, suppose if we again take this, take this, we put it here. Oops, give me just a second. And we hit P, so we paste it. What if we change this to super dot has eyes and make this public, which is actually a bad programming style convention in general. Don't make your variables, especially your instance variables, public because they're prone to be stolen. So that's actually a good encapsulation tip for all you guys out there and girls. So let's compile our code and we get another error. So what's the issue now? So it still can't find the method getEyes, and that's because it's looking at type animal. So even though it's public, even though it gets the proper variable, it can't find it because it's looking in the type animal. Let's fix that. Let's make it look in horse. Let's change the type to horse, and now maybe let's check if it can find it. So let's compile. Look at that, it works. Run, and it works. So that was the issue. Instance methods and methods in general will be looked for in the parent before the child. If you call a method that is not in the parent but is in the child that it inherits, it will not work. Now let's try something a little bit weirder. Now this may be kind of confusing to you at first. Let's have two getEyes functions, or two getEyes methods. Or in fact, let's actually just make it a normal method. No need to make it this accessor method. Let's reset our class, by which I mean let's make all these things, all the things that should be private, private, and everything that should be public, public. And let's actually define a new method. Now this method is kind of just a demonstration method. So we're going to return an integer and call it demonstrate inheritance. And we're not going to take in any variables or parameters, formal parameters as they're known, and we're just going to return 1. How about that? We're going to do the same thing in the superclass. We're going to call this the same thing. Let's see what kind of behavior we get. And here we're going to call it 0. We're going to call it 0. So now we're going to have an animal who contains a horse object, and we're going to actually print the value that the function returns instead of getting the eyes, because we've already done that many times. So let's try and demonstrate the inheritance feature that is most confusing to people, which is how to override methods properly. So to reiterate, this is an instance method. It is not a static method. Both of these method signatures are the exact same, except they exist both in the superclass and the subclass, and we'll see which one it calls. Let's do a Java C compile. Oops, we have an issue. Cannot find symbol. That's good, because we just made it private. So it is good that it's encapsulating. Oh no, wait, it's in the animal class, so we don't need the super. We just had to change the implementation because of the copy paste. Let's try it again. Good, it works. So let's try running this and see what happens. It says 1. Now let's go back and check what this 1 is talking about. So 1 actually comes from horse, which is weird because I just told you that if you have it of type animal, it's going to check an animal first for the method. Shouldn't it just check an animal for this method and, it finds it so it returns 0? No. For instance methods only, it goes to the parent first, or the superclass if you like to call it. It checks if it's there. If it is there, it will check the subclass. If the same method is overridden in the subclass, it will use that implementation of the method. Now let me reiterate. It will use the subclasses or the type of not the type. the name of the object, the class for which the object is defined, as the implementation for instance methods only. So for instance method, it looks at this, the implementation for animal, it says okay, it's there, so I'm safe, and it goes back here and checks, and if it's here, it's going to return the value of the implementation found in the subclass. Now, why does this happen? Well, there are a couple of design reasons why this is supposed to happen, and this is mainly because a superclass is the more generic interpretation of any Java feature. Like, for example, an animal may or may not have eyes, but a horse we know for a fact has eyes. It's a similar kind of idea here. An animal is more generic and a horse is more specific, so it may need to override certain traits, even if it's of type animal, of a more generic type animal. So let's check to make sure that we're still not completely wrong by doing this. Not completely misunderstanding, sorry. So let's actually comment out the parent method. The parent method that we previously overrode. And overriding, for people who don't understand it, is essentially just replacing the superclass's method of a particular method signature for a particular method with the same method signature but a different implementation. So let's get rid of, or just comment out, the superclass's implementation. We'll see what happens. Let's try compiling and let's just hope it works, and it didn't, because it can't find symbol of type animal. And that's what we expected, because it goes to the parent first. It goes to the type of the object first. And let's actually call it animal.java now. It goes here and it can't find this, so it can't go down to this because it doesn't know if it exists. So let's uncomment that. And let's actually make this static. And just as a reminder, static means it isn't associated with any particular object. So let's actually do two tests with the static implementation of demonstrate inheritance. As usual, we have the same method signature for both this one and this method in both the subclass and the superclass. And like I've said in previous videos, you can always use an object to call a static method. You simply cannot use the variable this in a static method or refer to an instance variable or an instance method. So let's try this out and see what happens. Same deal here. We're going to compile, run, except it says 0. Now, why does it say 0? For static implementations, or essentially just non-instance implementations of anything, the compiler always goes to the type. The type in this case is animal. It goes to animal and it checks whether the static method demonstrate inheritance is there, and it is, so it's simply going to use that. This is because static is a more generic version of a more generic implementation of a method. For example, if you have a static method, it isn't bound to any particular object. If it's not bound to any particular object, it can be used for any objects, and that makes it more generic. So to kind of flow with that a little bit, Java implementation, it looks for the first static method starting from the type of the object. Yeah, sorry. Okay. So we know that static goes to the first one. How about, let's actually think about this for a little bit. Let's try this. Let's make this public. Again, bad style. Let's also make this public. Public Boolean has eyes. Okay, so we've done something a little bit weird now. We've added has eyes to both this class and this class. And remember, when we call the constructor, it's only going to set the value of this has eyes. It's not going to set the value of the horse has eyes. horse has eyes instance variable. So let's actually try this. We've put has eyes in both of them. They are instance variables. Let's try and access has eyes and see what we get. As usual, we compile, we run, and it says true. Now, why is that? This actually goes out and finds the value for has eyes, and it stops right at the type of the object. And in fact, if we get rid of this, this should still work, because it would stop right before. Yeah, there we go. So the bottom line is, for instance methods only, it goes to the actual object that is being defined to find the method header, to find the method. Otherwise, it stops at the type. And if none of the instance methods, variables, static variables are found at the type, then it will error. So that's basically a summary of what we've covered so far. Thank you, and I will see you in the next video. Alright, for this final video on inheritance, classes, methods, static methods, instance methods, static variables, instance variables, all that sort of stuff, we are going to be writing a full implementation of the animal class. And you can see that I've already done a little bit of work here. We're going to work on it mostly together though. I'm going to try and restore this to the original state that it was, but it's been modified a little bit. We're actually going to have the number of eyes be a property of the animal instead of has eyes, because I've improved on my biology a little bit. Most animals do have eyes. Let's actually make the animal have a certain number of eyes. That's probably more specific. We're going to move our main method down here, because let's not have it interfere too much. Let's make this return an integer, and here we're just fixing up our old accessor methods. We don't need demonstrate inheritance anymore because we've already demonstrated it. Please feel free to go back to the previous video and take a look. We don't need this. Let's change this. I was messing around a little bit to make sure Java was working properly, or that I had the correct understanding of this. So let's take a look, and this is actually going to receive now. Sorry, horses have 2 eyes. I forgot. My bad. We don't have a this dot has eyes anymore. Okay, so we are at the bare bones implementation with the number of eyes. So let's actually expand on this a little bit more. Animals have a particular number of legs. They have a particular color, which will be a string. Now, keep in mind that these colors and legs, all that sort of stuff, is not determined. These are not determined as of now. They are received as parameters in the constructor. So we have number of eyes, number of legs, and we have a parameter for the color. And we can actually set all of these variables, such as num legs, to num legs. Keep in mind that this keyword refers to the instance variable, and the one without the this refers to the local variable. It is generally seen as a little bit of a weird style to have both the local variable and the instance variable be the same name, but I'm used to doing it from Python, so I carry it over to Java as well. As long as you use the this keyword with instance variables and no keyword with the local variables, you should be fine. We've set all our variables, and let's actually do something. Let's create a static variable, and this will also, no, let's make this public. Let's call this population. Let's call this population, make it an integer, don't forget your types. Save that. Alright, so we need accessor methods for all of these. We'll make a section called accessors, have it be in comments. Let's have an accessor for the number of legs, get legs, and have this return, have this return the number of legs. Let's have an accessor for the color, get color, and have this return the number, sorry, not the number, the color of the animal. Ooh, should be unindented. Okay. Now, do we want mutators? Mutators are methods that change the value of instance variables. In this case, we will, even though we won't be using it all that much. We will, just to demonstrate how it works in a full implementation of a superclass and a subclass. So let's make our mutators return void. A lot of mutators, especially in Python, return true or false, a Boolean value, just to see whether it has successfully changed the value or not. For now, we're just going to keep it as void. Booleans are used more in mutators, especially when you're checking for errors or checking for invalid values. Like, for example, if you set legs to a negative number, or if you set eyes to a negative number, it would complain. For now, we're going to ignore all of that, although we may explore it in the future. We're going to make them of type void. They're going to return void, and they're going to have name set eyes, except now this time we're going to take a parameter to what we should set the eyes to, and this is going to be the new has eyes. Let's actually make this called new eyes, because I don't want to be too confusing. So let's put a statement here that says this.num eyes equals new eyes. Again, don't need the this dot notation, but I would strongly suggest it. Another setter method, new legs. Same deal here. Num legs equals new legs. And note that we are actually changing the value of instance variables here. So this is an instance method. It cannot be a static method because static methods don't know what this means. The object this is unknown to them. So our last setter method is also a void method. This is going to set color, but it's going to take a string parameter. Now we've actually avoided talking about, let's call it new color. We've avoided talking about the elephant in the room, which is the population. The population also needs a setter and getter. However, since it is public and it is static, we're going to keep it without a setter and getter, although it should really have one. We're just going to try and demonstrate how it works internally, how static variables work internally with the Java inheritance. So we've got our mutators and our accessors. Let's go in our main method and empty it out. So let's talk about our constructor and horse, which is the subclass. Let's start our subclass implementation. So we know horses have 2 eyes, so that doesn't need to be changed. Horses have 4 legs, and they have a color. But horses have different colors. So we should really take the color of whatever horse we're talking about and set it. So let's get a color here and pass in that color variable to the animal constructor. So this is going to take whatever we pass in for the horse constructor as a color, and it's going to pass it in right to the animal constructor. And once it's there, we can use the getters and setters that the animal class has. So let's try that out. Put on our main method. Let's make it of type animal. What's a good name? Let's call him Joe. Is a new horse, and we need to pass in a color, so let's call this, horses can't be blue, brown. So now what we can do is we can print out all sorts of stuff about Joe and make sure we've implemented this correctly. So we have number of eyes, and we can print that out for Joe. Get eyes, and we have, whoops, a particular number of, sorry. Let's get rid of this line. It's bothering me a bit. Okay, there we go. It has a particular number of legs plus Joe.getLegs, and we're going to print a new line. By the way, this is an escape character that prints a new line, the /n. And then finally we're going to get the color, and we don't need to print any new lines, so we're done. Let's try this out, and if we did good coding, it will compile, and it did not. Let's see what the issue was. Oh, we forgot to change this from our previous implementation. This should say num eyes, not has eyes. There we go. Let's run that, Java animal, see what we got. Number of eyes is 2, number of legs is 4, and its color is brown. So it looks good so far. Let's actually change this a little bit and go back to make it a horse. Does it error? Let's take a look. If Java works properly, what we should see is that it works fine. And that is because whenever you find a superclass, whenever you find yourself in a subclass, if it doesn't find something, it will try and go up to a superclass and find the same thing. So the rule last time that it goes to the type, and if it doesn't find it, it goes to the subclass, only works if that type is a superclass. Otherwise, it goes to the subclass and it tries looking up for all the methods. Now, for example, suppose we take all these mutators and put them in the horse class, and we set the type of Joe to an animal. Now that would fail, because it's going to look for set eyes, set legs, and set colors in animal, and it's not going to find it, so it's going to error. Alright, so now we have a decently complete implementation of animal. We have a complete implementation of horse because everything that we need is inside animal. And that's pretty much it. So I'll see you guys in the next video. Alright, welcome back. We're going to be talking a little bit about iteration before we move on with more object-oriented programming. That is because after object-oriented programming, or during object-oriented programming as well, you'll encounter a lot of things that will require iteration and or conditional statements. So we'll go over this first. This is simply an explanation, a simple, quick explanation of how to deal with control in programming. So this isn't specific to Java, nor is it specific to object-oriented programming, which is what this course mainly focuses on. But this is just a quick revision if you've already done it, or a quick introduction to conditionals and iteration. So let's actually take a look at what conditionals mean. So conditionals are actually something that happens when a condition is true. From the name conditionals, you can probably ascertain what it means, and it's exactly what you think it means. The most commonly used conditional is the if statement. If we have an if statement here, let's just have an ellipse here for now. Obviously it won't work if you have an ellipse. And if you have an else statement here, this runs the body of the if statement, which is here. If and only if, this condition inside this parenthesis is true. Now you'll be able to evaluate this condition based on Boolean algebra. And if it's not true, we will run this else body. Now if this if body is true, it will never get to the else body. And that is called short circuiting. If it runs one of the if bodies, it will never get to the else body. Likewise, if it runs the else, it will never get to any of the if bodies. Now, we can extend this a little bit too. We can add else ifs function, else if blocks. Else if another condition, we will run another body. So let's trace through this together. So if this condition is true, it will run the first ifs body, this body right here. Sorry, this one right here. If that is not true, it'll go to this else if statement and check if this condition is true. If this condition is true, it runs this else if body. If that is also not true, then it will run this else. The else if is a catch-all in the sense that it will catch any value. It will catch any expression. Even if all the ifs and else ifs evaluate to false, the else will catch all of them. Now, in an if statement, you do not need an else if or an else statement. You only need the first if. So let's actually get back to our first if and experiment with this a little bit. Let's get rid of this comment here. Let's just say if true. And as you may know, Boolean algebra, true evaluates to true. So we're going to run this if statement, or this if conditional statement. And if it's true, we're going to print out, hey, it's true, with the apostrophe, because grammar or punctuation, one of those things. So let's try that. Let's actually clear the screen first. Java C iteration, Java iteration. Hey, it's true. So let's take a look at how that works. It's going to evaluate the conditional statement here. It's going to be Boolean. And if it's equal to true, it's going to execute the body. In this case, the body is just, oh boy. The body is just that. So it's going to execute that. In other cases, there may be else ifs. So let's see the behavior if that happens. Else if false, we all know false evaluates to false. So this else if should never run. Hey, this shouldn't work. And let's try that. Obviously it'll work because we've set this to true. What if we set this to false? What would happen then? Let's think about this. So since this evaluates to false, it wouldn't execute this first if body. Since the else if evaluates to false as well, it wouldn't execute this body either. And since we don't have an else, it has no fallback option. So nothing will be printed if we got this whole conditional thing correct. Yeah, so nothing is printed. Let's try and put in an else. So else if none of these is true, none of these are true, we're going to print out, hey, at least this works. So we're going to compile, run, and it says, hey, at least this worked. So we've succeeded. So this is the basic flow of an if statement. The last thing we're going to do is talk about this, the short circuiting of an if statement. Similar to short circuiting of Booleans, once an if block is run, doesn't matter if it's an else if or an else or anything, it quits the whole if block. So this whole block, this is one block. In these, there's one if block, there's one else if block, and there's one else block. It will quit this whole thing if one of these if statements is true or the else if statement is true. Let's take a look at how that works. So this is going to be false, so it's not going to execute the body of the first if. However, the else if is true, so it should execute the body of this, the second if statement. Let's take a look at what happens here. Let's compile the iteration code and run Java iteration. Hey, this shouldn't work. Oh, we didn't change the description, but either way we can tell that this is printed. But we can also tell that the else code is not printed, which means that it short-circuited out of this whole if block after it printed one of the if print statements. After it finishes the body of one if statement, it will quit out of the whole if block. All right. So now that we've talked about conditionals and short-circuiting, let's talk about iteration, which is what this public class is called. Iteration is kind of special in that it helps you do repetitive things very quickly. Iteration does things for long times. It does things periodically, and occasionally it does things forever. So the main iteration function that we're going to be talking about, the control expression, is the while loop. And this while loop is probably the most important iteration tool for iteration that's ever been invented. Many people use the for loop. For loop is a great alternative, but we're not going to talk about it in this class because it's not really as, I'm not going to say not as useful, but you can do pretty much everything that you can do with a for loop with a while loop. It's just going to be a bit longer. So let's actually set an integer I equal to 0. And while I is less than 10, we're going to print out I. And we're also going to set I equals I plus 1. So what we're doing here is we're saying while I is less than 10, this is a Boolean statement. This is similar to an if conditional statement. It's going to check a Boolean expression, and if it's true, it's going to execute the body of the while. The body of the while, the first thing is it's going to print out the value of I, then it's going to increment I. It's going to raise the value of I by 1, put it back in I. And then while that keeps happening until I is not less than 10, so suppose I equals 10. At some point I is going to be equal to 10. Is 10 less than 10? No, so it's going to quit out and it's going to stop. So this is going to print out all values from 0 to 9 if we're correct, because it exits right at 10. So let's try that out. We're going to compile, run. Hey, look at that. So it starts at 0, prints all the way until it's 9, prints the 9, and then it stops when it's at 10 because the Boolean condition is not satisfied at that point. Alright, so that's a little bit about iteration. You can use iteration with data structures, which we're going to see in the next video. And iteration is actually quite useful when you're dealing with arrays, for example, even with array lists. All this sort of stuff works very well with iteration since data is usually formed in lists or works somewhat like a list. Alright, well, thank you for looking at this quick look at iteration and conditionals, and I hope this was informative. Welcome back. In this last section of the course, we focused a lot on inheritance, we focused a lot on classes, the Java implementation of many of these concepts such as inheritance, encapsulation, abstraction, all that sort of stuff, but we still haven't discussed data structures. Data structures, as you may have heard from a lot of CS knowledgeable folks, is probably one of the most important parts of CS. One of the main things that data structures focuses on is making data, storing data in ways that makes it more efficient in the order of time and space. So that means that we want things to be fast and we want things to run on as little memory as possible so that we're conserving space and time. And there's actually some functions that describe it called the big O functions, or should be actually the big omega functions, that describe time and space complexity. We're not going to look at that a lot, but we'll talk about it a little bit. So I actually have a class here called data structures, and I have 2 instance variables in here, and I've yet to implement the class. So I have a thing called the array list, which I'll talk about a little bit in a little bit. We're actually just going to call it the list, and we have a string array, which it should recognize from previous videos. So we're actually going to put in a constructor, takes no variables, and we're going to initialize these array lists to be empty. So we're going to call upon the constructor of the array list. Now, note that the list cannot be instantiated because it is an abstract class or an interface. An interface is actually just a special version of an abstract class, which doesn't have any concrete methods. We're not going to talk about that in this course, but abstract classes and interfaces are very important in inheritance and all that sort of stuff. So if you want an extended look at what we did in the last section, please take a look at how the array list implementation works. But for now, you can just assume that list is some sort of parent or a superclass to array list, even though it kind of isn't. So let's make that happen. Let's obviously initialize the array. We know how to do that. We set the length of the array. Let's actually set it to 10 for now, and that's it. Both of these data structures are empty, except the array already has an instantiated value, while the array list we didn't specify any value. And we're going to take a look at how that works right now. Let's create a main method, static void main string args. You should have this method signature kind of boiling in your brain by now. It should be there, the snap of a finger. We're going to instantiate a new object data structures of type data structures. Data structures main equals new data structures. Obviously the constructor doesn't take any parameters, so we're good on that front. Let's make these public for now. Again, bad style, but we're going to just do it for the sake of this example, so we don't need to add getter and setter methods. Okay, so we got main.ArrayList, and that refers to our array list. Main.r refers to our array. And in fact, we should have probably made this static to make this a little easier. No need to instantiate an object, but that's okay. So let's talk about the array first and review a little bit. So the array, we can assign values to it. Oh my god, what happened? Okay, we can add values to it, set the first value or the second value or the first index as, I don't know, high. Set the second value, or I should say the third value or the second index as world. Get rid of this here. Set the third value to be my name is Java. Okay, so we've set 3 values. The first value is empty, first is high, second is world, third is my name is Java. But what happens to the rest? Well, the rest is empty. It's going to be initialized to a value of null, and we can see that if we actually print this out. And printing with arrays is a bit of a mess. You cannot natively print arrays. They do not have a toString method. Arrays don't have any methods. Arrays only have one instance variable, and that is length. So if you wanted to find the length, you would do main.array.length, but we don't need that right now. The way to print arrays is actually to call upon a pre-made function in Java util.arrays.toString, and you can print main.array, and let's check this out. So we're going to do Java C on data structures. Whoops, what happened? Oh, I forgot to do my imports. Well, the first thing I should have done is imported the required libraries, and in this case it would be the array list and the list. And while we're at it, why don't we just import arrays as well? Sorry, list. And in fact, we should import java.util.arrays, so we don't need to type that in when we get to the printing phase. So right here, since we've imported it, we might as well just call it by arrays.toString. So let's try it now. Looks fine. Data structures, let's run it. Look at that. So like I said, everything that isn't hi world is null. Now let's take a look back at our array list implementation, or list implementation if you will, and see how that works. Let's try and set a couple of values. Main.ArrayList, obviously call the index, set it to high, and let's try that. Ooh, what's the issue? Array required but list found. Okay, so we know that lists have a different implementation. We just have to figure out what that implementation is. So it turns out array lists in particular have a method that they use called get and set and add. So we're going to use these methods to add a variable high. So now that we know that array lists don't actually behave like arrays, even though they have arrays in the word, let's try using the add method to add to the array list. Let's add another element, hi world, and then we can try my name is Java. So as you can probably notice, we're mirroring exactly what we've done to our array implementation and see what carries over and see what doesn't. So let's compile, see if this works, and lo and behold it does. Let's try that. Ooh, what is that? Oh, that's just the array. We actually haven't printed our array list yet. And let's try printing it the same way that we printed the arrays and see if it works. Let's try that. Ooh, that's a big error right there. It says no suitable method for list string. Okay, so we obviously can't copy our array implementation. In fact, what we can do for array lists is just print them out. So let's try that. We can just type in main array list and it will print out beautifully. Let's check it out. Data structures. So let's take a look at this. This is the array implementation here, and this is the array list implementation. So as you can probably tell, the array has a fixed length, and you can set particular values, but you can never add values. The array list is completely different. You can add values, you can change the array list, you can change the size of the array list. In fact, if we print out the value of the array list before we do this third addition, you'll notice that the size of the array list changes. And we'll discuss why that happens right after we launch it. It does. So it starts out with size 0, size 1, and this is the printed version of size 2, and now it's size 3. So how does this work? Well, array lists on the inside, the way Java programmers and the people who made the Java library made it, they have had array list actually have an internal array containing these values. This internal array has a specific size, like all arrays do. This is actually just like this on the inside. This looks like that, except Java, using the ArrayList class, prints it out in a different way. Now, since this is size modifiable, we can keep adding elements. How does it work if they use an array on the inside? Because arrays have fixed sizes, as you can see through here. Well, let's take a look at how they would do that. Each time you get a particular number of elements, let's get rid of our prints. Each time you get to a particular number of elements, the array, the internal array, actually doubles in size. And the double value is actually, it's one of the most optimized reasons. It's called, there's a concept in Java called, I'm not sure how to pronounce it. It's called amortization time, but it runs in constant amortization time, which is a word that basically means it runs very efficiently if you double it before needing to double it again in the case that you've added more elements. So let's actually take a look at what happens here. So we're just going to keep adding numbers here. And remember, numbers are also strings if you put them in quotations. So this should work perfectly fine. Oh no, that looks ugly. Okay. Oh boy, here we go. This actually reminds me. Perhaps we should use a for loop. I is less than 100. Let's keep adding values to our array list based on that. Oh boy. Okay, now let's print out the array list at the end and see what we got. So I've added a couple of values before and I've added a couple of values after. Let's see what this prints out. Okay. This is a huge array. And I can tell you for a fact that the internal array size in the array list is not initially this size. It's initially definitely less than 10. I'm not exactly sure what the number is, like specifically, but I know for a fact that it's definitely less than 10, definitely less than 15. Since we've added more than 100 values here, this must have doubled over 2 or 3 times. And so the array list is actually a very efficient way to have an expanding array. And most data structures that require random access tend to use the array list. Let's talk about what random access is. Random access is actually common to both array lists and arrays. And random access refers to getting elements from a particular space. So suppose I wanted the 7th value in here, or actually the 8th, and the 7th value of my array. Now, the notations are different, but it works in the exact same way. Whoops. What's wrong here? Whoops, I forgot a concatenation operator. If you run this, what you will get is two values that describe random access to any index. So this gets the value, the 7th value, or the 8th value in the array list, which is 2, and the 8th value in the array, which is null, as you can see here. Alright, so this is a quick look at two data structures that are particularly useful in Java. There are others, which I urge you to study. There are sets, maps, there are actually maps are called dictionaries in Python. So if you're studying Python, they're called dictionaries. We also have lists and arrays, obviously. These are most of the data structures you will be using for Java, any programming course overall. But of these, lists and arrays are probably the most useful. So lists and arrays are both great at random access. They can get anything from any index at any time. However, array lists are expandable. You can add elements as you wish, and it will be a perfect implementation if you have a growing data structure. Arrays are much more memory efficient, and they require much more involved thinking about the length of the array and all that sort of stuff before initializing. Array lists are sort of modifiable and dynamic on the fly. So those are two data structures that will be very helpful to you, and I hope the add and the get functions will help you in your conquest to learn more about array lists. See you later.
Thank you for watching. For details, visit www.designyourcareers.org or send an email to info@designyourcareers.org. Subscribe to our channel, Design Your Careers, and hit the bell icon so you'll never miss a video.